All right, we're on. Hi, everybody absent. We should have quick figured. 8 out of 13 is what percent of the class is here?
Not much.
We're small in number, but large in brain power. We are. We are confident.
Happy hump day.
So, we're going to talk limits, but before we talk about how to calculate limits with equations, we of course need to set them up and calculate them by hand or by graph first so you get a concept here. So we're all going to draw this lovely graph. I am about to put a vertical asymptote at -6. That didn't go very straight, did it? I was supposed to have a line. We'll try that again. And now, of course, I don't get a dotted line. We'll try a third time. You're going to have an asymptote there. You're also going to have a horizontal asymptote at +2. Okay. And then we're going to put some curve action into this thing. And so part of this graph fits over here in this corner. It's not changing. Kind of like your hallway type curve. It's actually not a hallway. And then you will notice from the real origin, 1 over 1 down, we have an open circle. I'm curving that one backward and down this asymptote. And then 1 over and 4 up, I have a closed circle. This is at -6 over here. Going out to 5, 1, 2, 3, 4, 5, and going 6 up, 1, 2, 3, 4, 5, 6. I have an open circle. That's a 5. That's a 6. We have a graph connecting the two, and then it goes shooting downward.
Okay, that open circle, what's that coordinate? 6? Oh, sorry. Okay, never mind.
Okay. Now, point is, I want to talk about the limit values at different points on this graph. There's lots of interesting things happening here on this graph. This is obviously not your typical function. It's definitely not what? I did go through the asymptote. You can cross asymptotes. Asymptotes are only to show you where it's going as it extends toward infinity. This horizontal asymptote is there because it's showing us where this very left edge is headed down out toward infinity. It's going to follow the asymptote. We run the asymptote all the way across, but we don't have to follow it. So this here on the right side, yes, it crossed the asymptote and I'm headed down, and that's okay. As long as you're not headed to infinity, at that point, it's actually allowable to cross your asymptote. Okay. Anybody remember how we write the limit notation?
All I remember is the limit does not exist.
X arrow, and then I tell you a number that you're approaching, except actually I want to approach 5 first. Okay, you have to have the limit of a function. So you either need to put f of x there, or here in a few minutes we'll put the actual formula for that particular function will be written there, the expression for that function. So you have to have the limit of something. You can't just write lim and not have something there that you're taking the limit of. Okay, if you'll recall though, I can approach from several different ways. I'm going to put a little minus behind that 5. Anybody remember what that means when you say 5, a little minus on it? It comes from which side, the left or the right? The left, because the negative side is the left side. So that's saying approach 5 from the left-hand side. Because we are going to do that one, as well as then we're going to approach 5 from the right-hand side. And then we're going to approach 5 5 with nothing on it, what does that mean when I put nothing on it? That means from both sides. If there's no little left or right symbol, we're approaching from both sides. Okay, but let's do 5 from the left first. So if we're approaching positive 5, and notice that says as x approaches 5, that means your x coordinate is going toward 5. So if I'm cruising along the x-axis here, headed in toward 5 on the left-hand side, I'm trying to figure out what that graph is doing. In particular, does anybody remember what I'm looking for? It's what's happening as my x-coordinate gets really close to 5, I'm looking for what my what is doing. What my y-coordinate is doing. So I want to know as my x-coordinate is getting really close to 5, where's my y-coordinate getting really close to? Well, which part of this graph am I following right now? Yeah, this little piece right above these points. I'm following this piece right above these points. I'm following these y-coordinates right up here going, hey, guy, where are you headed to? So as I get really close to 5, what is my y-coordinate getting really close to? 6. Does it matter that there's a hole there? No, because limits only care about what happens when you get close. Limits do not care what's happening right on 5. This is what happens when you're getting close to it. And as we get close to 5, the y-coordinate is getting close to 6. Okay, what about approaching 5 from the right-hand side? So now I'm out here on the right-hand side coming in toward 5. So I'm following these y-coordinates on this graph, and as I get closer and closer, yeah, it's still getting close to 6. So that looks okay. Therefore, what's the limit from both sides? Okay, what has to be true before you can have a limit from both sides? The left and the right have to be coming toward the same number. If the left and right sides are not coming to the same number,
The limit does not exist.
the limit does not exist if the two sides don't match up, which is what Bailey is remembering. But this one, we got 6, and so yes, the limit for both sides is 6. And then finally, they're going to ask you to find what's f of 5. What's it mean? What's the difference in f of 5 versus the limit as we approach 5? That's the actual number. When you are right on 5, when you're actually on 5, what's the y-coordinate? Nothing. What do we call it when there's no point there? Undefined. No phone calls. Now that we've evolved back, and for those of you who are missing, the people here can officially hear now. We hope. And you all will probably get bugged to have to make up that hearing test. So, we just did limits approaching 5. 5 had a little bit of interesting aspects to it, but some of these others have a little more pizzazz to them. So this time I want to go look at what happens when we are approaching 1. Notice positive 1. So one more time, if I'm approaching 1 with the minus behind it, where am I going? We're going from the left side. So we're headed toward positive 1 here. And if I'm coming toward positive 1 from the left-hand side, which branch of this graph am I following? That tends to be one of my biggest problems is people start looking at the wrong piece of the graph. Am I looking at this piece up here, or am I looking at this piece down lower? Yeah, I'm looking at this one down here because that's where it lines up with the points I'm following. So as I get closer and closer to positive 1, where is my y-coordinate going? Negative 1. Once again, there's an open hole there, but it doesn't matter because limits only care what happens when you get close to the number, not what happens on the number. And while that seems like a who cares type of situation, these limits are going to set us up for tons more valuable applications in the real world, the idea of what happens when you get close to something. Okay, so right-hand side. Now if I'm coming from the right-hand side, that was a little toward 1, I'm following, once again, I'm up here on this branch, but I'm coming toward 1, so what's my y-coordinate going to be approaching? That's approaching 4. Okay, So when I say, what's the limit from both sides? It does not exist because the two sides don't agree. What do we write? Yes, we write D&E. 4 does not exist. Okay, now notice, it's a lot of times people confuse it. Limits do not exist. Notice over here when there was no point there, that's undefined. Points, when there's a missing point, it's undefined. A limit that does not match up from the left and the right does not exist. Keep the two straight. You can't mix them up. Okay. Then last but not least, what's f of 1? When I'm exactly on an x coordinate of 1, do I have a y coordinate? Yeah, this one's actually closed in up here, this one up here, so I can go up 1, 2, 3, 4. And so I have a value, I have a point there, but I don't have a limit there because the two sides aren't coming toward the same number. All right. Let's do a couple more here with a little pizzazz in them. Suppose I ask you the limit as we approach -6 from the left side. So I'm come to a -6, I'm on the left. Where's my y coordinate going? It is going up, 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 up. Since it's going up the asymptote, it's going toward which infinity, positive or negative? Positive. I don't care, you can put the plus on it or you can just write infinity, is whichever way. If it's, of course, if it's going to negative infinity, you have to put the negative on it. Okay. So what about if I approach -6 from the right-hand side? So now I'm coming from the right-hand side toward -6, and I'm following this graph. Where's it going? It's going down to negative infinity. If we're going down our asymptote. So if I ask you the limit from both sides, the two don't agree. Even if it's infinities, if they don't agree, then you still have it does not exist. And how about a point on 6? The exact point at 6. I should be writing -6, sorry. Where am I? Lily says undefined. What do y'all think? Is there any point on that asymptote? No, there isn't. So this one's undefined. Now, you can, y'all argued with me a little bit ago about the fact that I crossed the asymptote. Okay, you could, it can happen. You could have a point sitting out here somewhere right on the asymptote, and that would be legal. It would be a separate point, though. It is possible to have that happen. All right, last but not least, as far as looking at the graphs, we did not do these kind last spring. You have not seen this part before. What if I ask you the limit as x is approaching negative infinity? What does that mean? Because literally, you all have to learn to read the notation. This is not just busy work. We're not just writing the notation because it's... Read it. It says your x is approaching negative infinity. If my x coordinates are going toward negative infinity, where would those x coordinates be? Where are x's that are going toward negative infinity? Are they going down? Do x coordinates go down? X coordinates going to negative infinity, big negative numbers would be going clear to the left. So we're talking about if we extended this graph clear down out the wall of the building, if this thing keeps extending forever to the left, what's the y coordinate getting close to? Is it ever going to cross this asymptote? No. It's going to get closer and closer and closer to the asymptote, and it's never going to touch it. So that means it's approaching what y coordinate? What number? 2. That asymptote is at 2. So if we keep extending clear across the street, it's going to get closer and closer to 2. Never actually reach it. So when you're doing x approaches negative infinity, you're asking what happens if I go really far left? What if I said then, what happens if x is approaching positive infinity? What if I send my x coordinates as far to the right as I can? So as I extend far to the right, where's this graph going to go? It's going down, it's going down, it's going down, it's going down. We're going to have a really deep hole eventually. because we're going to keep going down forever. Matt says negative infinity. Is that the right way to write it? Is that where we're going? Negative forever? Yep. So that would be going to negative infinity. So when you see those going to infinity, it's what's happening on the far left, what's happening on the far right. Let's try it. Make sense to you? I can, but thank you. I will stop it.